Alright, in these next couple of sections, 12.1 and 12.2, we're going to be discussing exponent rules. Exponent rules are just a set of properties that we can use to simplify expressions that have exponents in them. And so to start our discussion, we should look at the definition of exponents. It's really the foundational principle that all of this is going to be built upon. So exponents, by definition, represent a repeated multiplication of the same factor. Okay, so you're multiplying the same thing to itself over and over again. And you guys have seen this before, so should not be new, but just to formalize it a little bit for you. You know, something like if I did 2 raised to the 4th power, well, that's equal to 2 times 2 times 2 times 2. It's 4 factors of 2. And so there's 2 parts to the exponent, the base and the power. The base is the factor that's being repeated, and the power represents the number of times it's repeated. Now if we wanted to actually evaluate this, we go through and perform those multiplications. 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. Okay. Now with exponents, you can raise numbers to powers, you can raise variables to powers. Doesn't matter what we're raising. And so a lot of the time you're going to see a variable like x raised to a power, like let's say x to the 7th power. Well, that's going to be 7 factors of x. Now it's a little bit of a pain to write them all out. 1, 2, 3, 4, 5, 6, 7. All right. And so the exponent notation is just a simpler way of writing this long string of x's. Okay. Now, what we're going to start to do is combine different exponent expressions and see if we can find some shortcuts in how to combine them. So I'm going to start out using a couple of x's and multiplying them together. Something like x to the 3rd multiplied by x to the 4th. Okay, so there's a multiplication. Again, I'm going to use this repeated multiplication idea to break down this first x into x times x times x. That's 3 of them. This other one over here is 4 more x's. 1, 2, 3, 4. And then they're being multiplied together, so I could bring the multiplication down. And so if I take my first 3 x's along with the last 4 x's and multiply them all together, how many total x's do I have? Well, the answer is 7. And so you're really looking at x to the 7th. And you can see by doing this, just very briefly, just from this example, that to get from the original powers to the final power, you would add them up. You add them because you're combining the first and the second together and just counting the number of x's there are. And so in general, we have a rule, and I'll put the rule in another color here. This is called the product rule. The product rule basically says if you have a power like x to the m multiplied by x to the n, so a product of 2 powers, then you combine them using the same base, but then adding the powers together, m plus n. Okay, so we're just adding the powers. Now a similar rule looks at quotients, or fractions. Instead of multiplying, we can divide. So if you consider something like x to the, well, let's go x to the 8th divided by x to the 3rd. So in this example, I'm going to have to write out 8 factors of x. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to divide that by 3 more factors of x. Now you guys know that when you have a common factor to the numerator and denominator, they can cancel off. So I can cancel off 3 factors of x, and I will be left with 5 factors on top, if you count those up. Okay, so that would be x to the 5th. Now notice that the way to get from the original exponents to the final is through subtraction. You take top minus the bottom to get the final. And that's because you're subtracting off when you cancel. Alright, so as a general rule, we're going to have something called the quotient rule, and it's similar to the product rule. The quotient rule. And that basically is going to say that x to the m divided by x to the n is equal to x to the m minus n. So here's our subtraction. Okay. All right. The next thing we're going to look at are 3 different cases where we compare the exponent on top and the exponent on the bottom of this quotient rule. And actually one of them we've already done. This first case is where the top has bigger exponent than the bottom, and you just get a nice variable expression here at the end by subtracting. But let's say for a moment that the 2 exponents had the same value, something like x to the 4th divided by x to the 4th. Okay, well, using this quotient rule, I could just write that as x to the 4th minus 4th, and 4 minus 4 is 0, and so I get x to the 0. Interesting. Well, let's also approach this another way. Anytime you have something divided by itself, you can cancel those off. You can cancel common factors. In fact, you could see it even more clearly if I write out 4x's on top, 4x's on the bottom, and cancel. When you cancel common factors, you end up with 1. If there's nothing left, the answer is 1. Anything divided by itself is equal to 1. And so what's interesting is because x to the 0 is equal to this fraction, and so is 1, they must be equal to each other. And so our rule then is called the 0 exponent rule. And it says that anything raised to the 0 power is equal to 1. Okay. Now the third case with the quotient rule is where the top has smaller value than the bottom. Okay, so something like x to the 3rd divided by x to the 5th. Right? So the top is smaller than the bottom. And so in this case, you have again 3 x's on top and 5 x's on the bottom. 1, 2, 3, 4, 5, yep. Cancel your common factors. Everything's gone from the top, so I'm left with a 1. The bottom has 2 factors of x, so that's an x squared. Okay, so if I just break this down, I'm left with 1 over x squared. Notice the 2 is the difference between the 3 and the 5, but it's left on the bottom because the bigger one was on the bottom. Another way to think of it, though, is using this quotient rule. And using the quotient rule, you would say that, well, I could write over here, x to the 3rd over x to the 5th is equal to x to the 3 minus 5. Right, you're subtracting using the quotient rule, and that gives you a negative 2 power. And so because both of these expressions, 1 over x squared and x to the minus 2, are equal to the same fraction, they must be equal to each other. Okay, so we can conclude then, in this case, that x to the minus 2 equals 1 over x squared. And in fact, you can imply that you can work this out for any negative exponent, just using a different combination of powers to begin with. And so we have something called the negative exponent rule. And the negative exponent rule essentially says that anything raised to a negative power, we'll call it a minus m, is equal to 1 over x to the positive power. It's the reciprocal of the positive power. Okay. A related rule for this is to, if you switch where the negative goes, you can rewrite this as 1 over x to the negative m equals x to the m. So if you have a negative power in the numerator, it switches to the denominator with a positive power, and vice versa. If the negative is in the denominator, you get a positive in the numerator. Okay, and I won't go through and give you the details of how that one works out, but it's similar to the other one.